Hi, this is question 2 from the Further Pure for January 2010 exam paper by AQA. I'd like you to have a try at this question first of all, so if you could pause the video and read the question and then have a go. Okay, I'm now going to provide a hint for this question. So if you could use the hint to try and answer the question yourself, that would be great. So in this question, we're given the we've got the paralleloiped, and we're given the position vectors for each of the vertices of our paralleloiped, and we want to show first of all that the area of ABCD is 37. So what we're looking for is this area here. So we need to show that area is 37. Okay, so what you may need to do here is you need to have a go at finding this vector here and this vector here, and finding the cross product of those vectors. This will then lead you into finding what the area of this is going to be. For part B, it's asking you to find the volume of the whole parallelogram, so the whole paralleloiped. So you will know the cross product of this at this stage, and you will be able to use that to do the scalar triple product, which will then tell you what the volume is. So the other vector you need to know at that stage is that vector there. For part C, you're then looking to deduce the distance between the plane ABCD and EFGH, so that's the top plane and the bottom plane. Well, because at this stage you'll know the volume of the paralleloiped, and you also know the area at the bottom. If you multiply the area of the bottom by the perpendicular height, that would also tell you the area of the paralleloiped. So that information should be, help you to find the distance between the two planes. Okay, I'll let you have a go at those questions using the hints that I've just given, and I will then, so if you pause the video now, and then I will go through the answers. Okay, well done if you managed to have a go at that. So I'm going to go through the answers to these questions now. So for part A, we're showing that the area of ABCD is 37, so I told you to go away and maybe find those vectors there. So what we should have done is have found that AB, so the vector AB, and I'll start over here, so this is part A. Okay, AB is going to be B take away A, so that's 4, 0, negative 3. And we also need to know AD, so the vector AD, and that's going to be D take away A, and that's going to be negative 8, 7, and 3. Okay, so what we need to do now is we need to find the magnitude of the cross product of these, and that will tell us what the area is. So I'm going to find the magnitude of the cross product. So what we're looking for is, so the cross product of AB and AD, and we want the magnitude of that. Okay, so if we find the cross product of AB and AD, so that's going to be okay, so the top one's going to be 0 take away negative 21, so that's going to be 21, and then the next one's going to be 12 take away 24, which is negative 12, but remember we take the negative of this, so that's going to be 12, and the next one is going to be 28 take away 0, so that's going to give me 28 there. Okay, so what we need to know is what the magnitude of this is here. Okay, that's what we're looking for. We're looking for the magnitude of this. So I'm going to say that this is going to be equal to, and it's going to be the square root of 21 squared plus 12 squared plus 28 squared, and I make that the square root of 1369, and the square root of 1369 is also going to be 37 units, which is what we're looking for. Okay, so we've shown that the area of ABCD is 37. Okay, part B is asking us to find the volume of ABCDEFGH. So what we need to do here for part B is we need to find the scalar triple product of AB, AD and AE. So we've already found the cross product of AB and AD over here. Put that down wrong there, haven't I? Okay, that should be AD, and I now need to dot that with AE. So what I'm going to work out is AB cross AD dot AE, okay, and that's going to be equal to, well, the cross product of AB and AD is here, so that's going to be 21 12 28, and I'm going to dot that with AE, and AE we need to work out, so AE is going to be, and I'll write it down over here, AE is going to be E take away A, which is 216. Okay, so that's going to be 216 over here. So the dot product of that is going to be 21 times 2, which is 42, plus 12 times 1, which is 12, plus 28 times 6, which is 168. Okay, and if I add all those together, I get 222. Okay, so the volume of this is going to be 222. Part B then. Okay, for part C, we need to deduce the distance between the planes ABCD and EFGH. So that's going to be the perpendicular distance from there to there. Just draw a right angle in there to show that's going to be perpendicular. Okay, so because I know that the area of this here is going to be 37 units, and I know that the area of this times by the perpendicular height gives me the volume, and the volume is 222, so that means for part C I just need to do 222, which is the volume, and I need to divide that by the area, which is 37, and that there should tell me what the perpendicular height is, and 222 divided by 37 is 6. And there you go. So there's our answer for part C. Okay, I hope you managed to get most of that yourself. and I will see you again next time.